In this session, we are going to take a look onto the EC2 Auto Scaling groups. Before we begin, so this is the target architectural diagram which you can see onto the screen, which we are going to implement in this session. So at a first glance, this target architectural diagram might look complicated, but don't worry, we are just going to start from a ground zero and we are just going to break down the whole architectural diagram into bits and pieces so that it's really easy to understand the EC2 Auto Scaling group. But here is a very brief intro about the auto scaling group. So as the name suggests, auto scaling, which means it is going to auto scale or auto create the EC2 instances into our AWS environment. And how to control those? So here we need to define the mean, max and desired. So these are the numbers, and these number denotes the number of EC2 machines which is going to be started into our AWS environment. So whenever we create a auto scaling group policies, then we define these numbers. So minimum is the minimum number of EC2 machine which will be running into our AWS environment, and max is the number where we will be running maximum number of EC2 instances into our AWS environment based on the load, memory and CPU uses. If there is a more load, more requests coming to your EC2 instances, then max number of EC2 instances are gonna run. So you don't need to control, the auto scaling group will take care of that part. So based on the traffic, CPU usage, memory usage, it is going to create and reduce the EC2 instances onto AWS environment. All right, so now you're a little bit aware about the EC2 auto scaling group policies. So let's try to compare the two approaches. So here onto the screen, you can see one is traditional setup without auto scaling. And here on the right hand side, you can see the EC2 auto scaling setup. So let's first take a look onto the traditional setup where we don't have a auto scaling. So here on the top, you will see a load balancer, and that load balancer will route the request to our VPC, and then it will go into the subnet and where we are provisioning our EC2 instances. So in the traditional way, when we don't have auto scaling, so requests will come to the load balancer and that request will be routed to the VPC, and then it will eventually end up onto our subnet where our EC2 instances are running. So in traditional setup, what we do, we just predefine the number of EC2 instances. So here you can see there are 3 instances which is running. So let's consider a case where you are having only a few number of requests coming to your application. So it doesn't make a sense to run 3 CPU onto the cloud environment because there is only few requests coming to your EC2 instances. So you just need to run only one EC2 instance, which is sufficient enough to cater those requests. But instead you are running the 3 instances. So what will happen is you will pay a cost for running 2 extra instances into your AWS environment, and that's not an ideal scenario. But when you compare with the auto scaling group, so here what it does, it just gives you the flexibility to create more instances and reduce the instances based on the traffic or CPU usage or memory uses. So what you do, you just create an auto scaling group where you define the mean, max and desired number, and these are configurable numbers. So you can put like 10 also, 20 also, it's up to you and how heavy your application is. So you just create an auto scaling group, and in that auto scaling group, you just configure these values, and so that it knows like how many CPU it needs to, or how many EC2 instance it needs to provision to cater those requests. So that's the difference between the traditional and the EC2 auto scaling group. And the benefit we get out of this auto scaling group is that you reduce quite a lot of costs, because generally what happens is like, let's take a normal scenario where requests are coming in a daytime, but during the night there are very few requests because everyone is sleeping. So in that scenario, you can reduce the count of a CPU running onto your AWS environment, and that's where the auto scaling group can help you. Alright, so let's start implementing this auto scaling group onto our AWS console. So this is our target architecture, but let's break it down and start with our first block. So first of all, we need to create the VPC. So let's go back to our AWS console over here, and here just type in the VPC. Click on the VPC, click on create VPC, select VPC only. Here just type the name test VPC. Here you need to enter the range of your IP addresses. So I'm just going to put this one. And rest of the details I'm just going to keep default, and I'm just going to click on create VPC. And if you go back over here, then here you can see the test VPC has been created. After we create the VPC, the next thing which we need to create is the internet gateway. So again, go back to your AWS console, and here on the left hand side, you will find the option for internet gateway. So click on internet gateway, create internet gateway, and here you can enter the name. So I'm just going to copy the name from my notepad and paste it over here. So click on create internet gateway. So name is internet gateway test. So all the resources which I'm just going to create, I'm just going to add a name test so that we can identify these resources. I'm just going to click on create internet gateway. And also we need to attach this internet gateway with our VPC. So here in the action section, you can find the attach to VPC. And here select, and here you can choose the test VPC. So select test VPC and attach to internet gateway. So now we have created the VPC, we have created the internet gateway, and we have also attached the internet gateway to our VPC. All right, so let's take a look onto the diagram once again. So now we have a VPC, we have an internet gateway. The next thing which we need to create is the subnet. So again, go back to your console. And here on the left hand side into the VPC dashboard, you will find an option for a subnet. So click on subnets over here. And here you need to click on create subnet. And first of all, since we are doing everything inside our VPC, so this subnet is also going to be created inside the VPC. So first of all, let's from the drop down select the test VPC, which we have just created. And here we need to enter the name. So in the diagram, although I have created only single subnet because I didn't find much place to explain this concept, but in actual we are going to create a two subnet, and those are going to be the public subnet present inside the VPC. Okay, so let's get back to our browser or the console, and here I'm just gonna paste the name of my subnet. So I'm just gonna paste the name, which is test public subnet 1A, and the availability zone I'm just gonna choose Europe Central 1A. That's why I have suffixed it with the 1A. Then we need to define the IP ranges. So I'm just gonna put the IP ranges here. So 12.0.1.0/24. So we'll have a 256 IPs available inside the subnet. And again, I'm just gonna add one more subnet so that we have a maximum availability. That's why I'm just creating multiple subnet, and that's really important for you also. So I'm just gonna copy the name once again, and I'm just gonna paste it over here, and I'm just gonna change it to 1B. Select the availability zone to central 1B, and here we need to assign the IP range. So I'm just gonna define over here. So again, here we have a 256, but the IP range is 12.0.3.0, and previously in the previous subnet we have a 12.0.1.0. So that's the basic difference between these two subnet. And after that, you can just click on create subnet. All right, so now we have created the VPC, internet gateway, and then subnet. The next thing which we need to create is the route tables. So here on the left hand side, you will find an option for a route tables. Click on create route tables. And here I'm just gonna put the name route table test public. So I'm just gonna create a public route table for it. And again, everything we are doing into the VPC. So I'm just from the drop down, I'm just gonna select test VPC. And I think that's it, and click on create route table over here, and the route table has been created. But this route table is not associated with the subnet yet. So what you need to do, you need to go on to subnet association over here, click on edit subnets, and here you can attach the subnets which we have just created in the previous step. So select both the public subnet over here, save the association. All right. Now our route table has been associated with our subnet, but this route table is also responsible for providing the internet access, and for that we need to create a route. So here in the route section, there is a edit routes. So click on edit routes, and here click add routes. So here we need to enter the IP. So this IP 0.0.0, which means we can this particular route table or any resource associated with route table can be accessed via internet. So all the public subnet resources will have access to internet. Okay. That's been done. So here click on from the drop down internet gateway, because internet gateway is responsible for providing the internet access. So here we need to choose the internet gateway which we have created previously. So that is internet gateway test. I'm just going to select that one. And after that, we are just going to click save changes. All right, so now we have created the route tables also. All right, let's take a look onto the diagram once again. So we have created these many resources so far. So the next resource which we need to create is the target group. So remember, in the subnet, we will be creating the EC2 instances, and those EC2 instances will be a part of a target group. So that when we will create a load balancer, so load balancer will point to the target group, and this target group will point to the EC2 instances. So this is how it's gonna work. So now we will create a target group, but this target group will be empty as of now because we are not going to create any EC2 instances yet. That will be created using the auto scale policy. But let's focus on this target group first. So let's go back to our AWS console and go to home. And here type EC2 over here, click on EC2, and on the left navigation in the load balancing section, click on the target groups over here, and here you can see there is no target group. So what we need to do is we need to create a target group. All right, so the target group is responsible for pointing the EC2 instances. So I'm just going to choose the instances over here. And here we need to put the name. So I'm just going to put target EC2 Apache because we are going to install Apache server inside our EC2 instance. That's why I'm just going to put the Apache 2. And after that, I'm just going to keep the things protocol as port 80. That should be fine. VPC we need to change. We need to switch it to the test VPC because we are working inside the test VPC. Protocol HTTP1, that's fine. Health checks, I'm just going to keep everything as a default and then click next. And here you can see available instances. So there are no instances which has been created yet. Those instances will be created by an auto scale policy. And then we are going to come back and take a look over here. But as of now, there is no instances running. So we are just creating a blank target group over here. All right, so now just click on create target group over here. Okay, so now we have created the target group, and the load balancer, you can see none associated. So there is no load balancer associated with this target group yet. So we are just going to create that load balancer also. All right, so let's revisit the diagram once again and see what the next resource we need to create. So the next resource we need to create is we need to create a load balancer. So again, go back to your console over here. So here we have created the target group, and this target group, you can already see it is not associated with the load balancer. So now we need to create a load balancer. So from the left hand navigation menu, click on the load balancers, click on create load balancer. And here we need to choose the load balancer. Since we are working with the EC2 instances, so I'm just going to choose application load balancer. So click on create name. So I'm just going to put ALB EC2 instances set with auto scaling group. Okay, so this is the name which I'm putting. Internet facing, yes, I want the internet facing. VPC, we need to select the VPC. So I'm just going to choose the test VPC. Select both the subnets over here. Further, security group. So this is important. So whenever we create a application load balancer, then we need to have an access from internet. So for that, we need to enable the HTTP port 80 for that particular load balancer. And here you can see this security group is only default one. So we need to create one more security group so that this application load balancer can be accessed from internet. So I'm just going to click on create new security group over here, and ALB security group for HTTP, as well as I'm just going to enable the not SSH, but I'm just going to stick with HTTP requests. And I'm just going to type allow HTTP request over here. And again, here we need to choose the VPC because we are working in a test VPC. So I'm just going to select test VPC over here, add a rule over here, choose HTTP over here, port is 80, that's fine. Source, I should put 000 so that it is accessible from everywhere. Okay, and after that, I'm just gonna click create security group. Okay, so this security group has been created. I'm just gonna copy this name. I'm just gonna close this window, and here I'm just gonna refresh this one, and here you can see ALB security group for HTTP request. So I just need to add that one also over here. Okay, so now in the application load balancer, we have put the name, we have selected the test VPC, we have selected the subnets, we have selected the security groups, In the listener and routing, so as you can see in the diagram, we have already created this target group, and now we are creating the application load balancer, but this load balancer needs to point to the target group. So this is where I'm doing it. So in the listener and routing, select the target group, and here you will find the target group which we have created previously. So I'll just select that one, go further on, and just check the summary over here. So this is the summary for our application load balancer, which is internet facing IP4. Here these are the security group default and the one which I have created for to allow HTTP requests. VPC, we are into the test VPC, and these are the subnet, and this is our target group. So which is pretty much this setup we are just trying to verify over here. So this is load balancer, target group, subnet, VPC. So these everything are in place right now. So okay, I'll go back to console, and after that I'm just going to click create load balancer. Okay, so it has created the load balancer. So if you go to the load balancer dashboard, so it is provisioning. So state is provisioning right now. So whenever you create a load balancer, so it might take a couple of minutes to provision the whole load balancer. So just wait for a while. So I'll be back when this provisioning of this load balancer has been completed. Alright, so after a couple of minutes, my load balancer is now into our active state. So let's get back to our target diagram and see what next resource which we need to create. So after creating the application load balancer, the next thing which we need to create is the auto scaling group. So this auto scaling group will also contain the template, which I'm just going to show to you. But let's get back to our console first of all. So in the left navigation menu, just below the load balancing, you will find a section for auto scaling. So click on auto scaling group over here, create auto scaling group. And here we need to enter the name of our auto scaling. But before that, let's take a look onto the diagram once again. So once we create an auto scaling group, then it is going to ask you like what kind of a EC2 instance you need to create. So for that, we need to use the launch template. So the launch template is basically a primary configuration where you specify that what kind of EC2 instance you want to provision or you want to set up. So this will contain primary like a T2.micro, what the CPU type, your AMI, whether you are going to use Ubuntu, CentOS, Red Hat, your security groups also, and also you can specify the public IP address. Do you want to assign the public IP address or not? So these are some few details which you can specify into the launch template, and then this auto scaling group is gonna use the launch template to create the EC2 instances. But this mean, max, and desired numbers are not part of a launch template, but this is a part of auto scaling group. So what happens is auto scaling group reads the launch template. It knows like what kind of EC2 instance it needs to create and how many EC2 instance it needs to create. For that purpose, it will read these parameters, that is mean, max, and desired. Alright, so let's get back to our AWS console and let's continue with our auto scaling group. Alright, so here is the auto scaling group. So first of all, let's assign the name for auto scaling group. So auto scaling group EC2 instances test demo. And here you will find an option for a launch template. So I have already created one launch template, but for this demo, let's create a fresh one. So click on this link below. So this is the link which I have clicked to create a new launch template. So here I'll just put the name LT and then EC2 instances Apache 2. All right. So after that, assigning the name to the template, let's go ahead, choose the AMI. I'm just going to choose Ubuntu because I want to have Ubuntu inside my EC2 machine. So select that one. That's been done. Instance type, I'm just going to select T2.micro. After that, key pair, just select the key pair if you have already created. Otherwise, you can create a new one from here. In the network setting, we need to select the subnet. So I'm just going to select the test public subnet over here. Security groups. So this is important because we are creating EC2 instances, and for those EC2 instances to serve the request, we need to enable the port 80 so that we can serve the HTTP request. And for that, we need to create that security group. And also we need, for SSH purpose, we need to enable the port 2022 also so that we can SSH into those EC2 instances. All right, so what I'll do, I just need to create the service group for that. So let's go to the VPC section, go to security groups over here. click security groups, create security group. So here I'm just going to put like a launch template security group EC2 instances Apache 2. All right, and allow SSH and HTTP requests. So this is just a description I'm just going to put over here. In the VPC, we need to enter the VPC where we are working. So we are working into the test VPC. So select that one. Add rule. So here I'm just going to choose first of all HTTP port 80 and allow everyone. So I'm just going to choose this IP, add one more rule and add SSH over here, allow everyone, and after that click on create security group. Okay, so now we have created this security group. Just copy this name, go to this launch template once again, and here we need to assign that security group over here. Okay, so that we have assigned. Okay, so here I have assigned the security group, and subnet it is complaining for, so I'm just gonna select some other subnet which is available. Okay, so I'm just gonna select this one. Remove subnet for EC2 auto scaling template. So we don't need to select any subnet. So I'm just not gonna include anything over here. That's okay. Let's go ahead. Auto assign public IV. So we need to enable this one also. So let's check once again. So we don't need to include subnet. We just need to include the security group to allow HTTP request over here, and SSH. That's also mandatory. After that, I'm just gonna stick with the storage volume. So 8 gigs, that's fine. Resource type, I'm just gonna skip it. It's just optional thing. So in the advanced detail, we need to install the Apache, and we need to have some custom HTML page so that it can show the host IP. Okay, so for that purpose, I'm just going to use this script which I have already copied into my notepad. So this is the script which is going to update the package, then it is going to install the Apache, and here it is going to update the content of a HTML5 which is going to print the host name. And if you don't know what is user data, then I have already uploaded the session for this user data section. So just go and check into the playlist. So that will help you to understand like how you can write the script which can be useful when you're bootstrapping or when you're starting your EC2 instance, so that whenever you start an EC2 instance, so these packages will always be installed. Okay, so that's been done. So I'm just going to click on create launch template over here and go to launch template, and here you can see our launch template has been created. Okay, all right, so let's get back to our auto scaling group. So we have assigned only the name. Now we need to select the launch template which we have just created. So just refresh this one, and here you will see the launch template. So LT EC2 instances Apache 2, that's the launch template which we have created. And here is the version. Since this is the fresh template, that's why the version is 1 only. If you have modified that template, then you might get a different version. So just select the proper version or the latest version in case you are modifying the existing one. So that's just a quick note for you. All right, so the rest of the details are quite okay. I'm just click on next. And here the launch template is this. Here the VPC we need to change, and we need to change it to the test VPC because we are working inside the test VPC. The availability zone, I'm just going to select both of it over here. Click next. Now here it will ask like the load balancing. So if you go back to our target diagram once again, so here we already created this load balancer, and this load balancer is already targeting attached to this target group. So we need to select the load balancer for this auto scaling group. So here go back to this attached to existing load balancer, choose from your load balancer target groups. So we already created this target group. If you remember this blue boundary, so this is our target group, so that we have already created. So we just need to select that one. So here you can see this is the target group which we have created. After that, VPC lattice integration, just keep the things default. We don't need to change it. Turn elastic load balancing health check. So we just need to enable that one so that it can do the health checks for our EC2 instances. Health check grace period 300 seconds. Since we are doing it for demo purpose, so I'm just gonna keep it to 20 seconds. But just change it if you want to have some other health check grace period for your EC2 instance. Okay, so click on next. So here, these are the things where we specify like what's the capacity, mean, max, and the desired. So if you see over here, so mean, max, and desired. So I'm just gonna put desired into 2, minimum 1, and maximum I'm just gonna create 3. Scaling, so I'm just gonna keep it none, but in case if you're interested into furthermore, then you can just define some policies. So what it will do, so based on the CPU usage, so if CPU usage is more than 70%, 80%, then also you can increase the EC2 provisioning. So that will create more EC2 instances for you, but just for this demo I'm just gonna keep it none. And after that, click next. Do you want to add any notification? No, I don't want to add any notification. Click next. Tags are also optional, so click next. And after that, you just need to click on create auto scaling group. And here you can see our auto scaling group has been created. Now the key thing is it is updating the capacity. So as soon as you create an auto scaling group, it will automatically start creating those EC2 instances based on the desired capacity. So here the desired capacity which we have specified is 2. So it will automatically provision the 2 EC2 instances for us. So let's verify whether it has provisioned or it is provisioning the EC2 instances or not. So click on the new tab and go to EC2 over here and click on instances running. So here you can see 2. And here you can see the 2 instances has been started, both are in running state, and status check is initializing. So as you can see, like when we created this auto scaling policy, if you take a look onto the diagram. So when we created this auto scaling group, then it started provisioning those EC2 instances into our subnet. And these EC2 instances are created based on these numbers, like what numbers we have configured. So we have configured 2 as a desired number. So that's why we are seeing these 2 EC2 instances has been created over here. So I'm just going to refresh it. So it will take like a couple of minutes more to properly initialize everything. And then we are just going to verify from our load balancer. Okay, so here you can see our EC2 instances has been initialized properly and the status check is passed. So let's go back to our load balancer. So from the left navigation menu, click on the load balancers and click on this load balancer, and here just copy this DNS and go to new tab and enter the. So here you can see we are able to access it. I'm just going to zoom in so that you can see the details. So here you can see the server detail and the IP address is 12.0.3.127. And if I refresh this, then it is going to change to 1.247. And if you go to our EC2 instances, then we can verify the IP address, which is the private. So here you can see 3.127 it is ending with. I'm just going to refresh it once. So one request is going to 3.127 and the other instances, this one, so which is 1.245. So I'm just going to refresh it once again. So here you can see 1.245. So as you can see, our load balancer is now routing the request to the EC2 instances properly. So let's check few more things like how the auto scaling works. So here in the auto scaling target group, here you can see the instance management. Here you can see both are into healthy state right now, and we are able to access that also. So now what we are going to do, we are just going to manually forcefully terminate one of the instance. Then how the auto scalings behave, it is going to provision another instance also for us so that we get the maximum availability. Okay, so let's close everything. First of all, I'm just going to close this one also. Let's go back to EC2. So I'm just going to open 2 tabs. So this is our EC2 dashboard. Here 2 instances are running, and I'm also going to open the target group. Go to target group, and yeah. So health check. Yeah, this is going good. Target. So yeah, here you can see the both status are healthy. So now what we are going to do, I'm just going to terminate one of the instance over here. So terminate instance, terminate. So as soon as you start terminating the instance, I'm just going to remove the running filter over here also. So soon it is going to start provisioning one more EC2 instance, because in this target group policy, if you'll see, in the auto scaling group, we have set the desired capacity to be 2. So if one instance is down, then it is going to provision another instance. So here you can see into the target group, I'm sorry, it's a launch template. I just don't want to go into the launch template, but I'm just gonna go into the auto scaling group, click on the auto scaling group and instance management. So here you can see, just refresh this one. It will take us some time to see the changes. I'll be back in a minute. I think it will take 1 or 2 minutes to update the status over here. So I'll be back and I'll show you those new instances. Alright, so after a minute, as you can see, the one instance has been terminated and new instance is into pending state. So it's already started provisioning one more instance for us. So in the health section also, if I refresh this one, so here you can see one is unhealthy because we have terminated manually and now it has started provisioning in another instance. So this is how the auto scaling works. So whenever you define an auto scaling group for your EC2 instances, so it will just act based on the counts which you have set up into the desired mean and max. So if you terminate, if any of the application is unhealthy, then it is going to provision a new instance for us. And then this is how we are just gonna scale the requests which are coming to our EC2 instances from a load balancer. So with that, we conclude our auto scaling session. And if you like this content, then I have also created a channel membership program for you guys. So if you are interested into the more in-depth level concept on AWS or any other DevOps topic, then I have some other sessions which are specifically created for channel members. So you can just be a member of this channel. So you can check those behind the scene or more in-depth lab session. And if you are interested into the similar content for future, then consider subscribing to this channel, because I have planned many of the similar session in the upcoming week and you will see similar topics onto my channel. And also just check the description section where I have posted various course links like Terraform, Docker, Kubernetes, Helm chart, and the previous there are many more lab sessions I have created for Jenkins also. So just go and check those courses also, which will really help you to gain more insights into the DevOps. So see you into the next session of our DevOps. Till then, take care and bye bye.